Okay, so hello and welcome to Science Club, CPN.
Thank you.
We were wondering what world would look like without mathematics.
Oh, that's a tough question. I think the mathematics is there whether we see it or not, whether we do it or not. The mathematics is always there. So it will emerge no matter what happens. And whether we do it explicitly or not, a bridge will or will not stand. And if we don't use it, then we end up with a lot more trial and error, And there are things where you do want to get it right the first time. You want the building to stand, the bridge to stand, the technology to work. So even if we don't think of it as being explicitly mathematics, we will be doing the thinking. And so the mathematics becomes the explicit expression of the work that we have to do regardless. There isn't a world without mathematics. There cannot be a world without mathematics. And the more we make it explicit, the more we can work on it, then the better we can make the world, and the more we can do things right the first time and discover things that we might otherwise not know.
Is it, in that sense, sort of intuitive, mathematics? Why do you love mathematics?
There are lots of things about mathematics where the maths tells you things that you know, that you think are obvious. But there are also places where the mathematics can explain things that are not obvious and can help us not make mistakes. Especially with statistics. There are things that happen with statistics that are completely unexpected. So as soon as you have 30 people in a room, you can almost guarantee that there will be 2 who have the same birthday. And that's only 30 people. You'd expect to have a 50-50 chance. You'd need at least 100 people or more, but no, it happens very early. So this is a result that the mathematics tells us that explains something that's completely unexpected. So some parts of mathematics are absolutely not intuitive. And this is one reason why studying mathematics can be so hard. You are guided by your intuition. It's a human thing to believe certain things are true and to be guided by that intuition. And yet sometimes we are misled by that. And the mathematics can help us to explain things that can otherwise look mysterious and which can otherwise deceive us. So the doing of mathematics can sometimes be very non-intuitive and sometimes can seem completely obvious. And that's part of the joy of doing it, is to find those things where it doesn't match what you expect and then realize that things are not what you thought they were. And the maths can help understand that and help explain that.
So is it justified to call mathematics the most difficult subject in school? Because children usually very afraid of, not really in love with mathematics.
It's certainly true that a lot of people get put off mathematics very early. And if you take them outside of that formal context of the classroom and do puzzles or games, build bridges, make rocket cars, then you can sometimes find that they're doing what they would do in school, but actually enjoying it and getting it right. And then you take it back where you say, okay, now let's learn from the mistakes of the past and learn how to do this and get it right first time. And it can become uninteresting and they can become disengaged. But if you learn to play a musical instrument, you have to do the scales, you have to do the arpeggios, you have to do the speed exercises, you have to do the drill. Without that, you don't have the underlying capability to play the music. And in mathematics, the same is true. To use mathematics in a wider context, to be able to use it to investigate things, you have to have the underlying skills. And they're not fun. You can try to turn it into a game, but it's not fun. It's something you have to do. And school is often full of that and sometimes we lose sight of why we are doing this. Every subject is difficult when you take it far enough. But what happens is that mathematics is sometimes seen only as these rules that we have to learn. It's the equivalent of having to do the exercises without seeing why we're doing it and how it ends up being useful. Mathematics has a very long history. There is a great deal to learn to get to the point where we can use it in the real world. So it seems difficult and it's hard to find a good way of teaching it to keep the excitement alive. And that's one of the things that I and many of my colleagues try to do, is to give the equivalent of a concert, to see why we're doing these exercises underneath, to see why it's engaging, why it's interesting and why it's useful. It is hard, but nothing that's worth having is easy.
So is that the reason why you combined mathematics and juggling?
Absolutely. Juggling was one of my hobbies, and I always just enjoyed juggling. I don't know why, but I enjoyed juggling. And then some friends of mine and I started to try to develop a notation for juggling, like writing for language or musical scores for music. We tried to come up with a notation for juggling. And we discovered that there were patterns between the juggling tricks, connections between the juggling tricks that we hadn't known. And by following those patterns, we managed to predict the existence of juggling tricks that had never been done. So we found new juggling tricks because of the patterns. And when that happens, there is maths underneath. This is what maths does. It finds, explains, and explores patterns. So we found new juggling. And I went and I told a few people about that, and they were fascinated first by the juggling, but then by the mathematics. So this is what I try to do, is juggling is just one thing that I use to try to show people mathematics emerging unexpectedly from places where you would never believe that there was any mathematics. And the juggling is the vehicle I use to try and create that excitement, to hook people into being entertained and then seeing the mathematics and thinking, maybe there's something going on here, maybe this is worth doing after all.
Thank you. So could you maybe show us some of your tricks?
Certainly. When people find out that I juggle, they often say, well, I can do two. And always what they mean by doing two is this. And the problem with doing that is that one hand is throwing this way, one hand is throwing this way. And if you get into that habit, it's easy to understand, but when you try and do that with three, suddenly it's very difficult. And if you watch my hands, they're moving very fast. Right? But there's a much easier way of doing three. And I want you to imagine I've got one ball in each hand and one ball in the air. And as that one in the air comes down, then I throw this one straight up so that I can catch that one. And now again, I have one in each hand and one in the air. So I do that on the other side. I end up with this. Much slower, much easier, much quieter. And then you bring it down and widen it out, and you end up with this shape. So this is the easy way to juggle three balls. But now I have to be able to throw and catch with my right hand and with my left hand. And that's why it takes a lot of practice. But this has been known for centuries, possibly millennia. There are other things that you can do though with just three. So for example, you can do this. Now a lot of people think that this is cheating, but it's not. It's hard. And of course, if you really want to do strange things, you can do this, or even do this. Now the thing about that is that that has also been known for a long time. And you can do things like this. But what happened was my friends and I found that there are other tricks. And what happens is, when we're doing this, we throw each ball in turn. But we don't have to. we can throw some high, some low, and just so long as they don't all come down at the same time, we can mix them up. So we can get different heights. We can get some going straight across, we can get some bobbing up a little bit, we can get some going really high, and we change the rhythm of what's happening. So we can do this. You can see here that some are only going half the height of the one going over the top. And because we get the different heights, because we get the different timings, the mathematics helps us to know what we have to do and what we cannot do, what we must do to prevent the balls from coming down at the same time. And what has not been known until quite recently is that there is the mathematics underneath this and how we can make that work.
Thank you very much.
You're welcome.